experience with the sine and the cosine. What do you remember about the sine and the cosine?
One goes through the origin.
The sine goes through the origin, original sin. Sine goes through the origin. So now we're going to be a little bit more specific in our graphing. So I'm on section 4.4 and I'm letter A, right there, where it says y equals sine x. This is the graph that we are doing for y equals sine x. I'm going to turn that zoom off because nobody's coming. Okay, so y equals sine x. I want you to start at the origin. You're going to draw your hill and your valley. Remember that shape? That's your sine. Only now we're going to put some labels on the picture. Okay? So the labels that you're going to have are the top of the hill, where it crosses, like the middle point, the bottom of the valley, and the end. And those labels are really simple. They're 90, 180, 270, 360. In other words, they're one trip around the circle. Remember doing our angles yesterday? They're one trip around the circle. Mary Kate?
If we were to get a problem that said y equals negative sine x, would it just be flipped?
Upside down. So you'd have the valley first and then the hill.
And then it would still be 90.
Those labels won't change, yeah. Now, on this axis, your labels are 1 and negative 1. Okay? Now, Mary Kate kind of hinted a little bit about what's to come. These are the labels for the standard picture. Okay? We can do stuff to the equation, like put a negative in, that will change the standard picture. But this is the framework that we start with. So please make sure that you have that copied down on your paper for A. Now B is the same thing, only it's cosine. Cosine, remember, does not go through the origin. So cosine looks like this. Now, when you look at that, you think, that is strange, but remember, it keeps going. So when you look at it like that, does it make sense to you? But we just look at this much of it. Again, that's 90, 180, 270, and 360. It starts up here, and it stops up here. The labels are exactly the same. It's one time around the circle, and this is still 1, and this is still negative 1. The sine and the cosine are going to have exactly the same labels. The difference is the sine starts at the origin, and the cosine starts up here. Now, the tangent is brand new to you. It's going to remind you of something. Let me draw it, and then you tell me what it reminds you of. What? Oh, okay. I thought somebody said something.
I think it was
The tangent looks like this. It's a totally different shape. It has an asymptote at 90, another asymptote at negative 90, and it looks like that.
So we didn't have this one before?
You did not have that one before, but you had something similar to it. What does that look like? Does anybody remember?
It looks like
the cubing function.
Yeah.
It looks like the cubing function. And now, the cubing function did not have asymptotes. It didn't have anything to hold it in. So this curve is held in by those asymptotes. And they're at negative 90 and 90.
So the tangent will always be the same picture.
That is the picture of a tangent, yep. Now, like Mary Kate was talking about, you know, if we put a negative in it, it's going to turn it upside down. But it's always going to have that shape.
Okay, so like, whenever we did sine, it was like that way. So if it was a negative, it would go that way.
Yep. We're going to do some, I have a feeling, here in a minute. All right, so the first three problems, A, B, and C, are your basic shapes. All right? Now, you will notice that the directions to the problems say sketch, but then it says list the period and the amplitude. All right, I erased my sine curve. Here's my sine curve. Okay. The period and the amplitude. Period is distance from beginning to end. That's period. Distance from beginning to end. So for a sine, we're going from 0 to 360, so the period would be 360. What about for a cosine? How far is it from beginning to end? 360, so the period's 360. Now, how about for a tangent? We're going from negative 90 to positive 90. 180. Those are the periods. When you get your picture drawn, the distance from beginning to end is your period. Now, amplitude. How high it goes, that's exactly right. So the amplitude for the sine is 1. The hills go up 1 and the valleys go down 1. How about for the cosine? It's 1 also. Now this one is wild and wacky. How high does that go? Yeah, so we say there is no amplitude. You can say it's undefined, or you can say there isn't any. Because amplitude is how high you go, and with a tangent, it just goes forever. There's no stopping it.
So no matter what, when it comes to tangent graphing, it will always be undefined.
No amplitude, yep, there will always be no amplitude. Tangents will never have amplitude. No matter what I put in them, no matter how we flip them around.
But the period can change.
The period will change depending on, we like stretch it out. Okay,
if you were to get like half tan x.
Okay, we're going to talk about that.
Oh.
Okay, just hang on. We got a whole bunch of graphs to do. Look at the next page. We got a bunch of them to do. But we need to finish D first. All right, so we've gone through, we've done amplitude and period. Now we're going to graph y equals 2 sine x. Exactly. Exactly. So y equals 2 sine x. This number, we talked about it back in chapter 1, that number out in front multiplies the amplitude. Back in chapter 1, we said it multiplies the height. But amplitude is the trigonometry word for height. Okay? Isaac, you're into music a lot. What does an amplifier do?
It makes the sound louder.
Exactly. What it does, these are sound waves. Sine and cosine are sound waves. So when you turn up the volume, see these hills? They get a lot bigger. The amplitude increases. That's the height of the waves. Okay?
That makes more sense.
It does, yeah. So we have increased our amplitude. This is like turning up the volume on your sine curve. Now, you're not going to change the shape. Well, you are. It's going to be stretched out. It's going to be taller. But it's still situated just like that. Now this is 2, and this is negative 2.
So the amp be 2 now?
Uh-huh. And this is still 90, 180, 270, and 360. We haven't done anything to the horizontal. A number out in front stretches it this way. So the period is still 360, but the amplitude is now 2. All right, now look at the next one. Now we have a cosine, but it has a -3 in front of it.
Which means
Okay, so now stop and think. It's a cosine, but the negative turns it upside down. So now think about that for a second. Your cosine is supposed to start up here. Now it's going to start down here. Would you agree with that? And instead of coming down and making a valley, it's going to go up and make a hill.
So we're going to start at -3.
So it's going to start at -3, and the top's going to be up here at 3.
Does it matter which one it goes through, like 90, 80, 270?
Yes, it does.
So every single
So
time.
this one has to be 90.
Okay, and the last one.
This one's 180. This one's 270, and then it ends at 360.
But not touching the axis.
Yeah, not at 360, because remember, it has to end where it started. So since it started down here, it's going to end down here.
Darn it. My hills are never going off.
I don't know, sounds like a personal problem to me. I don't know. So period is 360. We haven't changed that. But our amplitude is +3. Amplitude is height. So the negative is there, and it's important, but we wouldn't say the height is negative. The negative flip this over, right? So amplitude and period will always be positive numbers. Amplitude and period will always be positive. Negative tan x.
Can I try this one?
Mm-hmm.
Is it flipped?
It's going to be upside down. Now, will anything else change? No, we're just turning it upside down. So you're going to have tangent, remember, is the one that has an asymptote here and an asymptote
So would it
here.
start in the second quadrant?
And it's going to come down like this. That's exactly right. That
Can
is
you see that
exactly
lingo?
right. Huh?
The lingo?
Yeah,
Second quadrant?
yeah, second quadrant.
So the amp, no.
So, oh yeah, so period is still 180, right? Remember, period is how far it is from here to here. So that's 180. And amplitude is still none. Tangents will never have amplitude. Okay? All right. Let's see the next one. Oh, now, what's different about this one?
It's on the back side.
Okay, so the 1/2 is in a different spot. When the 1/2, or when the number is out in front, it multiplies your amplitude, right? Your height. When the number is on the x, it divides the period, or the horizontal. That's the same rule as we had before. I don't know if you remember it or not. Back when we were doing those weird pictures and I made you graph things like this. Do you remember that? You had the weird shape, whatever. This number right here is a divider. It divides. So, let's get the picture drawn. It's a regular sine curve. So I'm going to go ahead and draw my regular sine curve. It's not upside down or anything like that.
Oh, it should change the markings.
But so these are going to change now. Now, the height is going to still be 1 and -1. Would you agree with that? Because we didn't put anything out in front? But now look, I'm going to go ahead and show you how I do it here. I'm going to go ahead and I'm going to put the regular markings down here, because I want the real markings in my picture. So these would be the regular markings for a regular sine. Would you agree? But this number divides each of these. So these are going to all be divided by 1/2. Now remember, dividing by a half is the same as timesing by 2. So 90 times 2, now this label is 180. 180 times 2, this one's 360. You see what's happening? Everything is twice as long. So this is going to be 540, and this is going to be 720. So now my period is 720 degrees. It's twice what it was. What? I divide by this number, and remember, dividing by 1/2 is the same as timesing by 2. This number divides. So if you have your calculator and you do, like 360 divided by 1/2, it will say 720. So the period is 720 and the amplitude is 1, because we didn't change it.
Wait. Oh. Can we pray at the end of class today?
Can you what?
Can we pray at the end of class today?
You can pray right now.
You want to pray now?
You can pray. Do you want to pray?
Like
Because
out loud?
my prayer will always be, this is the day the Lord has made.
Are you going to lead us
Let
in
us
prayer?
rejoice and be glad. But if you want to pray, go ahead.
Yeah, Father, and the Son, and the Holy Spirit, amen. Dear God, thank you for giving us today. Thank you for giving us a healthy week here at Cathedral. Thank you for our support systems and our families and our friends who care about us. Dear God, please help us all stay safe over the weekend. Please help us stay on your path and guide us in this new chapter of our lives. Amen. Amen. Father, Son, Holy Spirit.
That was lovely. We also might think about like the homeless people, because they said it's going to get really cold this weekend. So hopefully they'll find a place to be warm. All right. Y equals cosine 2x. So I'm going to go ahead and draw my cosine. So here's my cosine. I'm going to put my labels. Now, remember, like I think it was Mary Kate said earlier, the labels are always going to go in the same spot. So here's where it crosses, there's a label. The bottom, there's a label. Where it crosses, there's a label. And then back at the end, at the top again. Those are where the labels go. Okay? Yep, sign out. Okay, now, the labels are supposed to be 90, 180, 270, and 360. So I'm going to go ahead and write those down below. But there's a number stuck in here. And what does that number do? It divides them all by 2. So my real labels are 45, 90, 135, and 180. And my amplitude is still 1 because we didn't change that with the number out here. Yep.
So you have a degree, so.
Amplitude, yep, and your period is 180 degrees. Yep, we're doing it in degrees. We could do it in radians. If you look at the graphs of the academic and honors kids, they'll be doing it in radians. But I made the decision we're doing degrees. So there you go. It's easier, it's less fractions in degrees. Okay, now we've got a tangent. Okay. So notice that regardless of the equation, I'm beginning with my regular curve. So I'm going to draw my regular tangent. I'm not going to label anything. I'm just going to get the shape in here. There are my asymptotes, and there is my tangent. Okay, now, what are these labels supposed to be?
-90.
Negative 90 and 90. what does that number do to my labels?
Multiply by 4.
Well, it divides by a fourth, which is multiplying times 4. So this is going to be negative 360, and this is going to be positive 360. So I'm not worried about this at all, but if I were doing this to scale, it would be wide, right? This would be a really wide one. As long as you have your labels, we don't need to worry about that. All right, so what's my period?
270. 360.
How far is it from negative 360 to positive 360? Well, from here to 0 is 360, and from 0 to here is another 360. So wouldn't that be 720?
Wait, what did I say 270?
Uh-huh. Everybody understand why it's 720? 360 on each side. And then what's my amplitude? It's a tangent. There isn't one, right? There isn't one. No amplitude. Oh no, look at J. Oh no.
Don't fret.
All right, let's not panic, like Mary Kate said. Don't fret. But let's get the picture up here. Now, it does have a negative in front of it, and it is a sine.
It's going to start down.
So we're going to start at the origin, because that's where sine starts, but we're going to do our valley and then our hill, right? And the labels will be the bottom of the valley, where it crosses, the top of the hill, and then the end point. You should have 4 labels. By the way, those are the 4 quadrants, those labels. Now, we need to put the labels in. This one's easy. 2 and negative 2. Would everybody agree with that? That's easy. Now, these labels, I'm going to go ahead and put down what they're supposed to be.
Multiply by 3.
And I'm going to actually divide. This number divides. So I'm going to divide by a third. So I'm going to take each one of those and divide by a third.
I actually can't really wrap my head around that.
Dividing by a fraction is multiplying by the reciprocal. So nobody does that division. Instead, we do 90 times 3. Yeah. Yeah. So that's going to be 270. And then this one is 180 times 3, so it's 540. You can use your calculator if the arithmetic gets out of your control. That's going to be 810, and this is going to be 1080. Dividing by a third. This number right here always divides. Always divides. Dividing by 1/3 is the same as timesing by 3. So I took all my normal labels and times them by 3. Okay? Now, what's my period?
1080.
1080. Distance from start to finish, 1080. And what's my amplitude? Positive 2. Very good. Remember, amplitude and period will always be positive numbers, no matter what. Okay? All right, let's see, that was J, so we're ready for K. So y equals 1/4 cosine 1/4 x. So we have 2 1/4s in the problem. They do different things. But let's get our cosine drawn first. It's a regular positive cosine. So remember, it starts up here, comes down, makes a valley, and comes back up. So your labels always will be where it crosses, where it bottoms out, the low point, where it crosses again, and then when it gets to the top again. It must stop where it starts. So if it starts up here, it stops as soon as it gets back up there. Now tell me about these labels. What will these labels be? That 1/4 and negative 1/4? Because remember, that number multiplies the amplitude, and these are supposed to be ones. Basically, isn't that number just going to be these? Yeah. Amplitude's easy. Period's not so easy. So we got to remember the originals are these. So write them down if you want. Those are the originals. And this time we're dividing them. This number divides. We're dividing them by a 4. All of them. So like Mary Kate said, who knows 90 divided by 1/4? That doesn't even make sense to me. So I multiply by the reciprocal. So this is 90 times 4, which is 360. And then 180 times 4, 270 times 4, I hope my math is right, and 360 times 4. Remember, you can always use your calculator if the numbers get too big. So what's my period? 1440. And my amplitude is? Oh no, 1/4? Oh, that's what you said, I'm sorry. 1/4. Are you getting the hang of this, sort of? It's not bad.
It's better than yesterday.
Good. That was K, so now we're going to do L. Now L's got something in there that might trick you. But let's start at the beginning. It's a tangent problem. So y equals 2 tan 1/5 x. So asymptote, asymptote, and tangent. That's my starting point. Now, what about this number out here?
Does it not do anything?
It doesn't do anything. Yes, Claire, yes. Because isn't that number supposed to change these labels?
Mm-hmm.
I don't have any labels there because there's no top to this picture. So I'm going to ignore that. The only time I need to pay attention to that is if it's negative, right? I don't need to pay attention to the number, but if it's negative, that means my picture has to turn upside down. Now, the labels are supposed to be negative 90 and positive 90. That I just have to memorize. That's what my tangent looks like. There is a 1/5 in front of this x, so it is going to divide those two numbers. So divide by a 5th, which is the same as timesing by 5. So this is actually 450 and negative 450. Would you agree? That makes my period what? 900 from negative 450 to positive 450. And what's my amplitude? None. Absolutely. Don't say 2. Remember, we're ignoring that. You guys are wizards. 2 more graphs, I think.
Mathematicians.
Yes, you are, definitely. Mathematicians. All right, why? Another tangent. Another tangent. So, William, you're following along here?
Yes.
All right. So we're going to start by graphing our regular tangent. Okay. So asymptote asymptote, tangent. There was another marker. Okay, now, my normal labels would be negative 90 and 90. But we have divided, right? Arrow. That divides. So I'm going to divide these by 10. So my new labels are negative 9 and 9, which makes my period 18. And of course, there is no amplitude. All right, y equals sine 2/7 x. It's a sine curve, regular old sine curve, so I'll sketch that and start at the origin. Your labels go at the top of the hill, where it crosses, the bottom of the valley, and where it crosses. Those are your labels. They're supposed to be 90, 180, 270, and 360. But what's happened? We've divided by 2/7. So 90 divided by 2/7. Remember, that number divides. So that's going to be 90 times 7/2. Is that 315? I don't know either.
320.
Somebody with a calculator.
Wait,
I have a calculator. What? Redhead?
If you were to do this without a calculator, would you do 90 times 7 divided by 2?
You could, absolutely. So that'd be 630 divided by 2. That's what I did too,
Yeah.
315. I just want to make sure I'm videoing this and I don't want somebody to come back and send me a nasty message. 315. So then the next one is going to be 180 divided by 2/7, which is 180 times 7/2. So that'll be 630. And the next one will be 945 because it's 270 times 7/2. And the last one will be 1260 because it's 360 times 7/2. Now I'm going to double check those just to make sure.
I checked them. Hey, we finished a whole section today.
You got time for more?
Yep.
That's enough for
Oh, there's never enough there. All right, so what's our period for this one? The period would be 1260.
Degrees.
Yeah. And I did not label my amplitude, so I'll do that now. Since there's no number out there, it stays as ones. So my amplitude is just 1.
Do you have to put the degree?
It's a good habit to get into. Am I gonna mark it wrong? If you don't, probably not. But it's a good habit to get into, for sure.
Do you want this extra marker?
What?
Do you want this extra marker?
Oh, no, you can keep it.
Oh, I haven't used it, so it's kind of just taking up space.
Okay, so what I want to do now is I want you to get out that Christmas gift thing that I gave you the other day. And I want to go through that.
You get no Christmas today?
No, I gave it to you the other day.
Why is it called a Christmas gift?
Because in the old days, when we like had school, A lot. I did all this, what we're doing right now, we did before Christmas. And so when we got to this point, we had Christmas break. And so I gave them this to keep them fresh on it over their Christmas vacation.
Smart.
Okay. Now, I've already done the first two on video with another class. So I'm going to start with number 3. Yep, I'm starting with number 3 because I want to get all this on video for everybody to have for review. So, starting with number 3 on the Christmas gift worksheet, and it says match the functions. Well, you're supposed to do this without your pink sheet, and what it means is match the reciprocals. Okay? So the sine goes with which one? Which one goes with the sine? Cosecant. Cosine goes with secant, and tangent goes with cotangent. So that's all we had to do with that one. Now 4 is one of our fill in the blanks. So I've drawn the picture for you. And the cosine is 4/5. Now, why did I label it like that? Exactly, Jada. It's adjacent over hypotenuse. So I know the cosine is 4/5, which automatically means my secant is 5/4?
Yes.
Right? Now, what about everything else? How am I going to figure out all the rest of these blanks I have to fill in?
Okay.
Pythagorean Theorem to find this. So let's do that. Pythagorean Theorem. 4 squared plus x squared equals 5 squared. Remember, 5 squared is the hypotenuse. It's always over here. So 16 plus x squared equals 25. X squared equals 9. So the missing side is 3. Is that what you got?
Yep.
A lot of times we get radicals, but that one worked out nice. So now can you fill this stuff in?
Yeah.
What's the sine? Remember, here's your angle. What's the sine? 3/5? Yep, 3/5. Which makes your cosecant 5/3. What's your tangent? 3/4, 3/4. Which makes your cotangent 4/3. Beautiful. Beautiful, beautiful. All right, let's see what's next. Find the exact value of the sine of pi/4. All right?
180 divided by 4 is 45.
Exactly. So first thing you're going to do is make that sine 45. 180 divided by 4. Then I drew the picture for you. Here's your 45, right?
45, 45,
And 1/√2. Now, sometimes we worry about negatives. Am I going to have to worry about any negatives in this problem? No, because I'm in quadrant 1. 45 is between 0 and 90, right? So I don't have any negatives. I'm in quadrant 1. I want the sine.
Square root 2 over 2.
So it's 1/√2, which is square root 2 over 2. Very, very good. It's opposite over hypotenuse. Now in the next one, remember this is just a bunch of random review to keep stuff fresh in your mind. Looking at the sides of that triangle, how big is angle Y? 30. Y is 30. Why is Y 30? Because it's across from the 1. Very good. So Y is 30, that makes X 60. So y is 30 degrees, x is 60 degrees. 7, same thing we just did, only this is cotangent pi over 3. Okay? What's pi over 3? 60. 180 divided by 3. So here's my 60-degree angle. So I know this is root 3, and this is 1, and this is 2. And I want cotangent, which is adjacent over opposite. So it'll be 1 over root 3, or root 3 over 3. And don't you feel like you're getting this kind of? I mean, it's not bad. All right, 8 is another fill in the blanks. So let's see what we have or what we know. Now, I didn't line these up across from each other this time. So you're going to have to remember what goes with what. All right, we know the secant is 13/5. Okay, what's secant? That's one of the reciprocals. Which one is it the reciprocal of? Cosine? So that means h over a is 13 over 5. So 13/5. It also means cosine is 5/13 because these two go together.
I'm still confused on how the adjacent moves.
The adjacent doesn't move. Every time you draw a coordinate axis system to draw your angle, which is all we've done in the last few days, adjacent's here, opposite's here. If you're on the coordinate axis system, it's always x is adjacent, y, or y is opposite, or yeah, x is adjacent, y is opposite. And you can remember that easily because cosine is adjacent over hypotenuse, and it's x over r. So x and adjacent are the same in standard position. Again, so you got to be situated on the coordinate axis system. All right, what do I need to do now?
You have to find the hypotenuse.
Got to find the hypotenuse.
Which is 12.
I know the hypotenuse is 13. I got to find the opposite side. So 5 squared plus x squared equals 13 squared. And you say you've already figured that out, Mary Kate?
Yeah. 169.
Yeah. Yeah, because x squared is 144, and the square root of 144 is 12. All right, so here we go. Sine is 12/13. Gee, you don't need our phone. Not in math class.
Oh, no.
Sine is 12/13. What's the reciprocal of sine? Which one does that go with? Cosecant, so that's going to be 13/12. Tangent is 12/5. And that makes cotangent 5/12. All right, let's get as much of this done as we can. Change 100 degrees into radians. Oh, gosh, who remembers how to do that?
Pi over 180
Oh, very good, Isaac.
is x over 100.
Yeah, pi over 180 equals x over 100. Perfect. So 180x, I'm cross multiplying, equals 100 pi. I'll divide by 180, and these are the kind that often you can cancel out some zeros to make your number smaller. So we have 10 over 18, which is 5 over 9, because they're both divisible by 2. we've already done a couple like this one. Cosecant pi over 6. All right, Chase, what am I going to do first?
5 1/8 about 6.
Exactly. So that's going to give me what, 30?
Yeah.
So cosecant 30. All right. Now I'm going to draw 30. Now remember, on the coordinate axis system, that's 0 and that's 90. So won't 30 be right here? Like that?
And so 60, 90.
What are you doing, Isaac?
Nothing.
Yeah. So 1, root 3, 2 are my sides. Across from the 30 is always 1. What's cosecant?
Sine.
Reciprocal of sine. So reciprocal of sine will be hypotenuse over opposite, which is 2 over 1 or 2. Number 11 is a check of your memorization. So opposite over hypotenuse is which function? Sine. So sine x, sine theta, sine, okay? How about r over x? That's a tricky one. R, oh, secant, absolutely. Now, if I don't have my pink sheet, I'm thinking, okay, wait, x is cosine, right? X over r is cosine, so this is the reciprocal, that's secant. Very good. Maybe I'll put thetas in there since I already got x's going on. Very good. X over y. Y over x is tangent. So x over y will be cotangent. That's exactly right. That's the cotangent. How about adjacent over opposite? Cotangent, because it's the reciprocal of TOA. So adjacent over opposite is cotangent. How about hypotenuse over adjacent? Hypotenuse over adjacent, somebody said secant, that's exactly right. Again, if you're not sitting there with your pink sheet, folks, cosine is adjacent over hypotenuse. This is that upside down, so that's its reciprocal, which is secant. And y over r, easy one. Y over r is, that's sine. Yep, y over r is sine. Okay. All right, let's do 2 more. Number 12. Find the cosine of pi over 4. I think we we've already done that. This is the 4th one of these we've done. Cosine pi over 4. William, step 1.
Divide.
So it's going to be cosine 45. 180 divided by 4. So I'm going to draw 45 degrees. And my sides are 1 root 2. All right, everybody with me here? So what's cosine?
Root 2 over 2.
1 over root 2, which is indeed root 2 over 2. That's exactly right. Adjacent over hypotenuse. All right, one more. We'll end on lucky 13. So the triangle is labeled. You have to look at the sides and tell me how big the angles are. 45, 45. Well, P and Q are both 45, right? Everybody okay with that? All right, let's start cleaning up our desks here. You've done a great job today. I am tickled pink.